Welcome, my name is Diego, and today I will present the paper titled Mobile Application, a serious game based in gamification for learning mathematics in high school students. The main problem we try to mitigate is the low academic performance of high school students in the subject of mathematics in Peru. As we can see in the last census evaluation of students, 65% of them were between the initial and pre-initial level with respect to academic performance. To mitigate this problem, we developed a mobile video game that uses gamification techniques to motivate mathematics learning. Our research began with the analysis of 30 scientific articles belonging to the Q1 and Q2 quartiles published from 2018 to 2021. These articles were composed of research projects evaluating the effectiveness of video games on learning and were classified with respect to four questions. What areas of mathematics have different investigations of mathematics learning covered? What academic level has the different research on math learning covered? What gamification techniques have been applied in learning mathematics? And what gamification techniques have been applied in learning? The first and second questions helped us identify the least research areas of mathematics and target audiences. We found out that out of 18 investigations, only 3 focused on high school. In addition, there was not a wide variety of mathematics areas investigated. Out of 18, 15 evaluated the area of arithmetic, only 1 the area of probability, and 2 in geometry. These two findings are important because they indicate that there is a lack of research to discover whether video games can be effective motivational tools for other math areas and for more mature students. That is why we decided to develop a serious video game oriented to students of the last grade of high school for the learning of trigonometry. The other two last questions helped us to identify which gamification techniques we could use to maximize motivation. Our series game is called Matified. It is a mobile video game used by students and relies on a web infrastructure. The gamification techniques avatar, progress indicator, rewards, and levels were considered for the game design to maximize motivation. This in turn was measured by three metrics: user experience, perception of gamification techniques, and perceived satisfaction with game-based learning. In Matchifight, all players have an avatar that represents them in the game. This avatar has attributes such as health, attack, and defense, which together determine how strong an avatar is in combat. The player's avatar also has secondary attributes such as level and experience. Experience is gained by defeating an opponent in a battle, and reaching a certain limit increases the avatar's level. As an avatar's level increases, so do its combat attributes. Players empower their avatar after defeating opponents. To do so, they must solve math problems by selecting the correct answer within the game. When solving a problem, players inflict damage on the opponent, which is calculated according to the attributes of their avatar and the opponent. In total, there are 3 levels of difficulty for the math problems. The hardest level gives more time to solve and doubles the damage the player would inflict on the opponent. In this way, we encourage players to practice the more difficult problems. Players' avatars can be equipped with 6 objects to increase their defense and attack, in order to be stronger when fighting against opponents. These objects can be purchased with gold, which is a virtual currency obtained by defeating opponents in battle. In Mathified, we use 4 gamification techniques to maximize motivation. The first is the avatar, which is an entity through which the player can interact in the game. Players can customize their race, gender, and skin color so that they feel identified within the game. The second technique is rewards, which are stimuli that serve to reinforce a desired response. Every time a player wins in a battle, they will receive golden experience. With these rewards, their avatar will be able to become stronger in subsequent battles. The third technique is levels, which are a way of measuring a player's progress in different stages, based on a difference in difficulty. In Mathified, before starting a battle, players must select a level. The higher the level, the more rewards the player will receive, but the opponents in the battles will have stronger attributes, which will make the battles more difficult to win. The fourth and final technique is the progress indicator, which allows players to monitor their progress. In Mathified, there are indicators so that the players can identify which math topics and math problem difficulties they need to reinforce the most. The procedure of the game is as follows. First, the player logs in, then goes to the battle menu, then selects an area of mathematics, in this case the only area is trigonometry, then selects a topic from that area, and finally selects a level. Upon selecting a level, a battle starts, and the player proceeds to select a difficulty level for the math problem to be solved. At the same time, a timer starts, and its time depends on the difficulty selected. After that, the player chooses the answer to the problem, and if the answer is chosen after the timer ends, then the player's avatar takes damage. Otherwise, it is evaluated if the selected answer is correct. If it is correct, then the opponent takes damage. Otherwise, the avatar takes damage. If after selecting the answer, the avatar or the opponent are not defeated, then the battle continues, which means that the player will select a difficulty level so that he can solve another math problem. Otherwise, if the enemy is defeated, then the player receives gold and experience as a reward and the battle ends. On the other hand, if the player is defeated by the opponent, the player can choose the option to start another battle. To validate that Mathified can motivate students to learn mathematics, we designed an experiment. The experiment had a total of 14 last grade Peruvian high school students and consisted of a 1 hour long presentation in which we showed all the features of the game. After their presentation, a qualitative survey was conducted assessing user experience, perception of gamification techniques, and perceived satisfaction with game-based learning. Additionally, questions were asked about possible additions to the game. More than 60% of the participants agreed or strongly agreed that the game is creative, easy to learn, supports them in their learning, interesting, novel, attractive, and innovative. More than 64% of the participants agreed or strongly agreed that the use of levels, rewards, and progress indicators would motivate them to continue playing. 90% agreed that other courses should use serious game for learning. In addition, it is noted that 80% agreed to recommend the use of serious game to their friends and acquaintances. Finally, the most requested feature to be added to the game is the multiplayer mode. This is an indicator that competition between players would increase the motivation of the game. In summary, the serious game Mathified was developed for learning the mathematical area of trigonometry for Peruvian students in the last grade of high school. Four gamification techniques found in the literature were used to increase players' motivation. An experiment was conducted with 14 students to evaluate the motivation generated by the game. Results show that with respect to user experience, more than 60% of the participants agreed with 7 aspects of the game. Regarding the gamification techniques applied, there was a positive reception with respect to motivation, about 60%. With respect to perceived satisfaction, more than 50% of the sample perceive a high degree of satisfaction with the use and recommendation of games for learning. For future works, we recommend discovering the impact in motivation of other gamification techniques, and also social aspects such as a multiplayer mode. We also recommend conducting experiments with a larger sample to obtain more accurate results.